continue in 5.5. Now let's look at a nonlinear inequality in two variables. And as I mentioned earlier, these will be our parabolas. So the graph is not going to be a line, it's going to be a parabola. I think parabolas are the only ones we're going to investigate here that are not linear. So we'll start off just like we did before. We need to graph the boundary line, so that means we'll replace the inequality, the less than, we'll replace it with an equal to. X squared minus 9. We should recognize that as a parabola that goes down 9 units. It opens up, and since the original had a less than, didn't have the equal to, has the less than, then my parabola I'm going to graph is going to be a dotted parabola. So let's graph a parabola that comes down 9 units. So I've got that point 0, negative 9. It opens up, and I'm just going to draw it as a dashed parabola. So there's the boundary. The boundary is a parabola, graphed as a dotted line. Now I have to decide which side to shade. I can use the exact same procedure as before. Pick a test point, and notice 0, 0 is not on the boundary line, so I can test it. Let's see if it's true or false. So let's test 0, 0 back into the original. So the original is y less than x squared minus 9. Let's put a 0 for y, a 0 for x, and I get 0 is less than negative 9. So I have to decide if that's true or false. So is 0 less than negative 9? It's not. So if the test point comes up to be false, which part am I going to shade? It's either going to be the inside of the parabola or the outside of the parabola, and since the inside was false, I'm going to have to shade the outside portion. So show some shading here, the outer portion of your parabola. Not too bad. Now let's put these together as a system. So we'll graph both linear and nonlinear inequalities together, and we need to find the solution. So let's take a look at it. It involves graphing each individual inequality just like we did in the previous two examples, but we'll put them together in the same coordinate system. Then what I have to do is find the region where the shadings for both graphs would intersect or overlap. The region where they overlap is going to be our solution, or the region of intersection is the solution to the system. So it gets kind of crazy here, so you've got to be careful with your shading so you can determine where they're going to overlap. So I'll use different colors here to help. Let me split this system up into its two parts. X minus y is less than 1, and I've got 2x plus 3y greater than or equal to 12. So let's work on graphing each boundary line. Since this is a less than 1, well, let's go ahead and put the associated equal to in. So I'll have x minus y equal 1. And this boundary line is going to be a dotted line. So find a couple of points, or choose your method of graphing that line. If I put a 0 in place for x, I get a negative 1 for y. 0 in place for y, I get a 1 for x. Two real simple points to find. So 0, negative 1, and 1, 0. And I would graph this as a dotted line. So there is my first boundary. Then I'm going to have to figure out which side I'm going to shade. Well, 0, 0 is not on that line, so we can pick it as a test point. So we can test 0, 0 back into the original problem. So for x minus y less than 1, I'll have 0 minus 0 less than 1. So is 0 less than 1? Yes. Now I'm not going to do any shading yet. I'm just going to kind of hold off on that. Let's graph the boundary line for this guy, which is the associated equation, 2x plus 3y equal 12. This one's going to be a solid line because it has the equal to. And again, however you want to graph it, I just find it real easy to graph it by finding a couple of points. 0 in place for x will give me 12 divided by 3, which is 4. 0 in place for y will give me 12 divided by 2, which is 6. Two real easy points to find. So 0, 4, and 6, 0. There's that line, and we're going to graph it as a solid line. Oop, didn't want to do that. Well, do the best you can. That's the best solid line I can get on this slick tablet. And let's do the same thing. Let's figure out what side of this line we're going to shade. So we'll do the same thing. We'll test 0, 0. Right there. Because it's not on that boundary line. So the original is 2x plus 3y greater than or equal to 12. Let's put a 0 for x, a 0 for y, and we'll have 0 plus 0 greater than or equal to 12. So is 0 greater than or equal to 12? No, it's not. So the test point for this one is false. Now, let's kind of put this together. For the dotted line, I found out that the test point was true. So this was for the dotted line. The test point was true, so I'll shade in this direction. So my dotted line gets shaded in that direction. For my solid line, which is here, I found out that the test point was false. That means for my solid line, I'm not going to shade the side with the test point. I'm going to shade the opposite side, which would be here. Now, where do the two shadings overlap? And it's easy to see because of the two different colors. And so your final result, the only shading you should have is the part where the shadings overlap. So I would need to have just this portion shaded in my final answer. Why did it do that? That's the final shading. I go back and make sure I've got everything shaded in the right direction. A dotted line, put in 0, 0. 0 is less than 1, so it's true. So for the dotted line, 0, 0 was true. Shaded that direction. Solid line. There's my graph. 0, 0 was false, and so it would be the other side. Okay, I think that's right. Be really careful. Use colored pencils, markers, whatever you need to do, or shade them both with pencil, and wherever it's dark is the final shading. Now let's do the same thing with a nonlinear inequality. So here we actually have a parabola and a line. So we've got a parabola and a line. So we're mixing these up. So let's do what we did earlier. Let's just kind of do one at a time. Y greater than or equal to x squared minus 4 and x minus y less than or equal to 2. And let's graph the associated line, or in this case parabola, the boundary line, by putting in an equal to. And I know that this one's going to be solid because it has the equal to right there. Well, it's a parabola. It goes down 4. I don't need to find any points. 1, 2, 3, 4. So it's a solid parabola. Does something like this. Now, let's decide where to shade. So I'll use 0, 0 as my test point. So if I test 0, 0, in the original I'll have 0 greater than or equal to 0 squared minus 4. 0 greater than or equal to negative 4. Well, 0 is greater than -4, so the test point here is true. I would end up shading the inside of my parabola. Now let's go to our line. We're going to graph x minus y equal 2 as a solid line. And again, just a couple of points, however you want to graph that. 0 for x will give me a -2. 0 for y will give me a 2. So I've got 0, -2, and 2, 0, and a solid line going through those. And we'll test 0, 0. Again, we can test it because it's not on that line. 0 minus 0 less than or equal to 2. So this says 0 is less than or equal to 2. Is 0 less than 2? Yeah, it's true. So the line, here's my line, goes through 0, -2, 2, 0, is going to be shaded towards the 0, 0 point. So this one's going to be shaded in that direction. Now what we have to do is do a final shading of where both the blue and the purple or pink overlap. And we can see, I can see by using two colors, the region where we see the shadings overlap is this part here, bounded by the line and the parabola. There, where the two shadings overlap.